This is part 3 of Module 9. For this part of the lecture, we will be discussing high-performance liquid chromatography. So again, take note of the corresponding pages in the accompanying textbooks on HPLC. High-performance liquid chromatography is also a separation technique, just like your gas chromatography. However, a distinct advantage of HPLC is that it is not limited to volatile compounds. With HPLC, you can actually analyze a great variety of substances, from organic molecules to inorganic ions to even polymers and biomolecules. So all you have to do is to change the mobile phase and stationary phase pairs. Alright, so shown here are the different separation modes under HPLC. So as you can see, the manner of choosing, or the criteria for choosing which separation mode you should be using is based on the solubility of the substance or the analyte, and also its corresponding molecular mass. Alright, so if you have organic soluble analytes, okay, separation modes that you can use can either be the reversed phase or the normal phase. Well, actually both of these are useful, no, for analyzing both organic and water soluble analytes. Okay, now for ionic compounds, okay, or ionic or ionizable organic molecules or even biomolecules, you can use what you call your paired ion chromatography. It's a variation of the reverse phase chromatography, or you can even use an ion, what you call your ion exchange chromatography, which uses an ion exchange resin. Now for larger molecules, alright, so you have yung natawag na size exclusion chromatography. Alright, so dalawang klase. If your analyte is an organic soluble polymer, for example, then you call this technique your gel permeation. But if you are analyzing water soluble macromolecules, such as your biomolecules, proteins, enzymes, then the particular size exclusion technique is called your gel filtration chromatography. Shown here is the typical block diagram for an HPLC unit. Okay, so when you talk about HPLC, para kang tubero, no? So basically this is plumbing. Alright, so you have a reservoir of the mobile phase. We call this your solid reservoir. Alright, which contains your eluent or mobile phase. Okay, then you have a pump which will allow the mobile phase to travel along this pipeline. Let's call that your pipeline. So through the sample injection unit, through the column, okay, to the detector, and then towards the drain. Okay, now an important part of the LC unit is the degasser. Okay, because remember that we are aspirating the mobile phase at very high pressures. Okay, so you want to remove any dissolved gases because bubbles might form along this narrow tube. So narrow tube lang ginagamit sa LC. Yung internal diameter niya is nasa millimeters lang. Okay, so you have to memorize this block diagram, and then we will be discussing each of these parts in the succeeding slides. Okay, so first let us talk about the solvent delivery system, or yung pump. Now, yung mga lumang units ng LC, mayroong mga other types of pumps, but for modern LC units, you have yung tinatawag na reciprocating piston pumps. Okay? Now, the solvent or the mobile phase, prior to um, installing it doon sa unit, it should be filtered. Okay? Filtered usually using a 0.25 micron porosity filter medium. Usually, the filter medium is either nylon, okay, or cellulose acetate. Okay? If you are nylon is very good, no, kasi you can use it to filter both organic and water-based mobile phases. Okay, however, it's quite expensive. Okay, cellulose acetate, on the other hand, can be used for water-based solvents, no, pero bawal siya sa may mga kahalong organic solvents, no, because cellulose acetate can is soluble in organic solvents, no. And then you have to degas, no, the solvent, no, prior to use, the mobile phase prior to use. Okay, so in some laboratories they have helium purging, or as you will later see, no, there is such a thing which we call your online degasser, which is based on a membrane, okay, semi-permeable membrane. Now, these procedures are important kasi remember, you are forcing the solvent, the mobile phase, into a tightly packed column. Narrow, tightly packed column. Okay, so if you have particles inside, it will really clog up the column. Alright? Whereas with the dissolved gases, it will form bubbles, no, inside the tube, no, and even into the column, which will increase the back pressure and might also damage your column, no. So yung column yung heart ng ating chromatograph, and it is also consumable, no. So we want to do our best to prolong the serviceable life of your column kasi may kamahalan yan, no. Usually mga nasa 50 to 60,000 pesos yung isang analytical column, no. So sa tingnan. Alright, so for the reciprocating pump, piston pump, so normally this consists of a small chamber. So you have a small chamber here where the eluent is pumped by the movement of this reciprocating piston, no. So if the piston retracts, no, paatras, it will aspirate the solvent, alright, going into the chamber. Okay, and then the succeeding push motion of the pump will push the solvent towards the column. Okay. Now, check valves ensure the unidirectionality of the flow. Alright? So, yung mga check valves ito, yung pinakapambara niya is yung mga ball check valves, no? Normally, this is made from ceramic, such as synthetic sapphire or synthetic ruby. Alright? So, kung ma-imagine, no, pagka umatras yung piston, ano mangyayari? Itong check valve na ito ay bababa, whereas itong check valve na ito ay aangat, no? So, itong part na ito mag-o-open to allow the solvent to enter, whereas this part here will be closed, preventing the solvent from the column from being sucked in, no, into the back to the chamber. Then the forward motion of the piston, ano mangyayari? Yung check valve naman na ito ang magbabara, no, magsasara dito, preventing the mobile phase from going back to the solvent reservoir, whereas this valve, wall check valve is open, alright, forcing the mobile phase into the column. Okay. Now the plunger seal, okay, this plunger seal here, this is made from a modified rubberized material, no? Prevents your solution from being drawn into the pump head, no, dun sa motorized pump head. And since there is wear and tear in this part, the plunger seal is actually consumable. So you have to take note of this, no? Merong lifetime lang ito at ina-expect na papalitan ito regularly, no, yung plunger seals. Normally, pagka meron kang high back pressure, okay, at you suspect na galing sa pump yung source, no, usual suspects are your check valves. Okay, so normally from time to time you have to clean this up. Okay, kasi pwedeng merong dumi that prevents your check valves from moving freely, okay, during the pump operation, and thereby increasing back pressure. Okay, so typical mobile phases, or sorry, composition of the mobile phase. So water, okay, for aqueous mobile phases, alright. So for water, we usually use type 1 water. Ito yung tinatawag na ultra pure water. Alright, so then you have your organic solvents, okay. Please take note that you want to use what you call HPLC grade solvents, no? So HPLC grade solvents are purified and pre-filtered, no? in a way that minimizes possible contaminants that might appear in the detector or might be detected by the detector. Alright, so if a solvent is typically contains preservatives, yung sa AR form, no? Yung HPLC form niya or HPLC grade na form niya, preservative free. Okay, because these added components might interfere in the analysis. No? So example ng solvent, no, na pagka AR grade ay typically contains preservatives would be your tetrahydrofuran. Okay, so if you have an HPLC grade THF, it's preservative free actually. Okay, now another important thing that you have to remember about organic solvents as mobile phases is that if you're using a UV vis detector, okay, this LC unit, you have to consider yung tinatawag na UV cut-off of the solvents, no? Because remember, these organic solvents may have also absorbances, no, in the UV region. Okay, so you have to take note their corresponding lambda max values. Okay, ayan. So you have your common organic solvents are methanol, isopropanol, acetonitrile, tetrahydrofuran. Buffers can also be used, okay, as your mobile phase. Mobile phases that are mixtures of buffers and organic solvents. Here they call the organic solvents organic modifiers. Okay, so it's also common practice, no, in HPLC. Ion pairing agents is sometimes added, okay, to modify the elution of your analyte. So when you add ion pairing agents, the technique is now called your ion pair chromatography. Okay, non-polar organic solvents are also used, no, especially for normal phase chromatography, no? So you have yung mga hexane, xylene, benzene, toluene. Alright, so again, just be mindful of the UV cutoff and kailangan HPLC grade. Next, you have your pump modes, which is analogous doon sa temperature settings for gas chromatography. Alright, so first you have your isocratic elution. In isocratic elution, the mobile phase composition is constant or fixed during the whole chromatographic run. So for example, if you're using 50-50 combination of water and acetonitrile, then for the whole chromatographic run, yun lang ang composition ng mobile phase. Okay, and it's usually useful, no, if the components of the sample are not, the polarities, for example, are not close to each other. Alright, now for problematic samples or multi-component samples which are difficult to resolve using a single composition, mobile phase composition, you might want to do gradient elution. No? So sa gradient elution, the mobile phase composition is varied during the chromatographic run. So say you start with alright, so kunwari, no? So ito yung plot kunwari ng time, alright, versus percent. So, kunwari, dalawang mobile phase ang ginagamit natin, no? A plus B. Alright. So, let us plot this y-axis in terms of A. Alright. So, for example, you start with the injection. After injection, you start with pure B. Okay. Then, after some time, you increase to 50-50 A, 50 B. Then you increase again after some time to say 75A, 25A. No? So yan, this is gradient illusion. Alright? And this is to to enable you to really resolve complicated mixtures. Okay? So, for gradient illusion, medyo kakaiba lang yung pump, no? Because you need a binary or quaternary pump, no? Which will allow you to mix, no? Change the composition of the mobile phase during a chromatographic run. Okay, so mas mahal yung content, yung units capable of gradient illusion. Alright, so the pump system incorporates, of course, a mixing chamber. Alright, whereas a high pressure system uses multiple pumps. So yung pagkaiba nito. No? So these two are actually analogous nga doon sa temperature settings, no, ng gas chromatography, no. So isocratic illusion, if you remember, is analogous to your isothermal run, whereas your gradient illusion is analogous to your temperature programming, no? So this is one way, no, of remembering things, no, by remembering the analogous pairs, no, of concepts. Marami yan sa chemistry. So next, we have your online degasser. Again, the purpose of which is to remove any dissolved gases in your mobile phase before it enters the chromatograph. Okay? Why? Because if you have a high pressure environment, no, yung liquid nyo is subjected to a high pressure environment, the dissolved gases will tend to form bubbles, okay, which may disrupt the rhythm of the pump, as well as this will cause high back pressures also, no, when these bubbles passes through the column. Okay, so shown here are two of the common types of online degassers. So you have here the online helium purge method. Although to be honest, I haven't seen this one, no, in the Philippines. What is common here is this one, no, yung gas liquid separation membrane method, which utilizes a polymeric film tube which is permeable for gases. Okay, so pag dumaan dito yung mobile phase natin, the dissolved gases are removed, no, from the mobile phase. Now, some other practices, no, to really reduce the amount of dissolved gases would be to sonicate your mobile phase. So after preparing your mobile phase, kunwari mixture ito, after filtering, no, so prior to use, diba, for the filter yan, normally we sonicate the resulting solution for around 15 minutes siguro, no, in a sonicator with a little bit of ice to prevent heating, no? And this will help the removal of dissolved gases. So next, you have your sample injector port. This is something I left out from your handout, no? So please take note of this. A common design for the sample injection port is the so-called Ryodyne 6 valve port design. Alright, so it looks something like this. Now, it has a valve, then you have here the parang syringe port, no? So the sample is also injected via a micro syringe. Similar to the one used in gas chromatography, no? Medyo different na yung volume and design. In general, larger ang volumes for liquid chromatography, okay, compared to the liquid samples injected in gas chromatography. Okay? So, yung construction ng microsyringe, similar lang din, no? It's made from glass with a stainless steel plunger. Okay. Now, the way to inject the sample, no? So the valve here has two positions, no? You have the load and the inject positions. All right. Now, doon sa likod nung sample injection port is you have there what you call the sample loop. Now, the sample loop is just a small capillary with defined volume capacity, no? So it's rated, no, depending on the volume, no? So pwedeng 20 microliters, 30 microliters, so on and so forth, no? So it's actually interchangeable, no? Pwedeng palitan from time to time. Okay? Now, so the valve has two positions, load and inject positions. All right? So when the um, valve is in the load position, no, as this diagram shows you, what happens is that the injected sample, okay, is trapped inside this loop, wherein the flow, so during the injection kasi the pump is already operating, no? So there is already uh, the mobile phase, no, being pumped at very high pressures. So at load position, hindi dadaan, no? So the mobile phase will not pass through the loop. Okay? So it will be redirected directly to the column. Alright? Now, if you switch the valve position in the inject position, what happens is that the mobile phase will now pass through the loop itself. Okay? So if you already loaded the sample, no, injected the sample into the loop, then the mobile phase will sweep away, okay, readily the sample into the column. Okay, so this is how the injector port works. Okay, so yung procedure, no, for injecting the sample, you place the uh, tawag dito, the valve position in inject position first. All right, then you insert the syringe, no? So the syringe already contains the sample. Now do not uh, inject the sample yet, no? So you just insert the needle fully into the injector port, then you switch to load position. Okay, so in switching into load position, this usually primes the computer, no, telling the chromatogram recorder, no, that you are about to inject the sample. All right, so after switching the port in load position, you push in the plunger of the syringe, micro syringe, and then when you're ready to record the chromatogram, you just switch back the valve, alright, into the inject position. Alright, so readily the computer, the system will start recording, no, yung chromatogram at time 0, no, when you switch to the inject position, no. So afterwards you pull out the syringe. Now the volume of sample being injected can be measured either via manual, no. So for manual injection, manual volume measurement, you use the syringe volume. Okay, kasi graduated naman yung micro syringe, so you measure the volume via the syringe. Alright, so ang tip dito is you should be injecting, okay, a volume of the sample not greater than half of the volume ng sample loop. Okay? The disadvantage of this is that medyo mababa yung repeatability or reproducibility ng volume being injected into the chromatograph. Alright? But the advantage is that you can readily change the volume of sample injected, no, as you would want. Okay, alternatively, you can do the loop volume method, no, which will depend on the volume of the sample loop. The advantage of this method is that it is more precise. Ang disadvantage nga lang is that you cannot readily change the volume of sample injected. No, you have to change the loop. So to change the loop, you have to turn off the system, the machine, and then use wrenches, no, to detach, okay, and reattach the new sample loop. Okay? Normally, for the loop volume method, you need to inject at least 3 times the volume of the sample loop. Okay, so this is to ensure that the sample loop is completely filled with the sample. Okay? I forgot to mention this for gas chromatography pala, no? For gas chromatography, okay, so when you don't need any ports, no? Kasi gases naman yung sample mo. So the mobile phase passes through the mixing chamber inside the sample injection port, no? For gas chrom. However, once you inject the sample in the port, there is no way for the machine to know that you already injected the sample. Unlike here in HPLC, the changing in the position of the valve will automatically trigger the recording of the chromatogram. So for GC, there is actually a button, no, very near the sample injection port, no. So once you inject, no, you press the plunger of the microsyringe, you quickly press that button so that the chromatograph can start recording the chromatogram. Alright, so this is our sample injection port. The column for HPLC can also be um, thermostated, no, inside a column oven. Okay, although not as important or not as essential as in gas chromatography. No, kasi sa gas chromatography, the purpose of heating the column, alright, or the environment of the column is to ensure that your analyte is in the vapor phase. But for liquid chromatography, there is no such requirement. If ever the procedure requires you to use a column oven, one purpose of which is number one, to reduce the viscosity of the mobile phase, which in turn will allow you to implement higher flow rates. So the higher the flow rate in general, the faster the elution time. Okay, so ang kalaban ng lagi sa liquid chrome is yung back pressure na nagde-develop. Normally, for conventional chromatographic runs, no, sa LC, a back pressure of not greater than 3,000 psi is okay. Okay, but pag yung back pressure mo is lumalagpas na ng say mga 6,000 psi, it will cause column damage already. Alright, so yung mga columns may nakalagay yan na ano no, na may parang operational back pressure siya, no, na kaya niya i-withstand, no. So never operate your columns at back pressures higher than what is indicated in the package insert. All right. Now another reason for controlling the temperature of the column is to improve the separation efficiency. Okay, as we all know, the manner by which your component separates is dictated by an equilibrium, no, yung distribution equilibria. And just like any equilibria that you encountered in chemistry, temperature plays an important role in this equilibria. No? So there are protocols, no, that requires you to have a thermostated environment. No, so isothermal lang, no, ang ginagawa ng oven. Usually up to 40 degrees centigrade lang, no, yung column temperature setting, no, if you are to use a column oven. Alright, so next let's focus on the column, which is the heart of the HPLC. So for the stationary phases, two of the most common materials used are silica and those that are based on polymeric resins. Okay, now silica is the more common one, okay, because of its well understood chemistry. Alright, so silica as a stationary phase can be used either modified or as unmodified. Alright, so silica, no, medyo interesting to. So for example, this is your silica particle. Alright, so the formula is SiO2. Now the nature of the terminal SiO2 bonds, no, or yung surface, no, yung chemical surface would look something like this. Alright, so the terminal groups, which comprises the surface of your silica, contains what we call your silanol group. Silanol group. Alright? Now, this silanol group is, as you can see, no, analogous to your alcohol group. So, they are polar in nature. Alright? So, if you're going to use unmodified silica as stationary phase, then what you have there is a polar surface. Okay? Now, the silanol group per se is also ionizable. No? Kasi yung silanol group, alright, at high pH can be converted to its deprotonated form, no? And in this form, no, in this particular form, this can serve as an ion exchange. All right, an ion exchange surface, no, for ion exchange chromatography. Now, to convert your silanol group into a polar group, all right, all you have to do is to perform some silanization reactions, no? So how do we do that? Let's erase this first. All right. Alright, so let's erase this first, no? So erase it. Alright. So for the one of the common, okay, groups, no? Non-polar groups is what we call octadecyl silane, no? So for octadecyl silane, so you have your silica, then you have your silanol group. Alright, you attach here your octadecyl, so that is 18 carbons, no? So CH2 17 CH3. Alright, so the reaction, no, for converting the surface into a non-polar surface, no, by reacting it with an alkyl chain is very much well established, no? So that's why for non-polar stationary phases based on silica, okay, walang kahirap-hirap, no? So you have yung C18, no, which refers to your 18 carbon, so octadecyl silane, ODS. Okay, you have your C8, no, for example, octyl silane group. You can even attach phenyl groups, no, if you want an aromatic ring, no, as your functional surface. Alright, so very easy, no, to modify, and even attaching some ion exchange groups, no, for example. So again, we draw your silica, no. So for example, you want to attach, say, a sulfonic acid group, alright, which is used in which can be used as a cation exchange resin. Alright, so very easy to convert the surface into whatever functionality you might need. Alright, now those based on polymeric resins are commonly used for size exclusion chromatography, wherein you need to have defined porosity of the material, and more commonly as ion exchange resin, alright, for ion exchange chromatography. Okay, now a word of caution when using derivatized silica, yung mga for non-polar. The problem with this one is yung usable pH nila, no? So the usable pH for bonded silica is around sa acidic range, no? Mga around 3 to 8, no? pH 3 to 8. Higher than pH 8, you will be cleaving this bond. Alright? So if you cleave this bond, you will revert back to your silanol group, no? Which is something that you don't want whenever you're using a non-polar stationary phase, no? Because this kind of cleavage, no, and you get this unwanted silanol groups will lead to tailing. Alright? Because this group is actually very polar. Alright? So this will lead to tailing. So over time, Okay, we all know that the column is consumable, no, in HPLC. So over time, for non-polar silica stationary phases, talagang nagde-degrade sila, no? Especially when you're using basic mobile phases or you're using a lot of water, no? Water cleaves this bond also. All right, so you need to be very careful, no, and really observe the proper storage conditions, proper operating conditions, no, for your column. Okay? Hindi ko yata na ilagay dito, no? But for columns, may required silang storage solvents. Alright? So, you need to check the package insert. Ano yung gagamiting storage solvent. As much as possible, you want to use water-free storage solvent, no, for the non-polar silica, no? So, normally, acetonitrile or methanol yung ginagamit dyan. Okay, so never let the
so
column
let's talk about the
dry
different
separation modes under HPLC. For the separation modes, important things that you have to remember are what are the type of stationary phase, mobile phase, and elution order, okay, expected for that particular separation mode. Alright, so first we have your reversed phase chromatography. The stationary phase used are non-polar stationary phase. So this is a modified silica. Example nga kanina, no, yung octyl silane, octadecyl silane, or the phenyl functionalized silica. Mobile phases are polar mobile phases, no? So water can be used, methanol, acetonitrile, tetrahydrofuran, mixtures of these, even buffers can be used, no? And even ion pairing agents can be added into your mobile phase. Okay. The first phase chromatography can be used for a wide range of compounds. All right, from organic molecules to ionizable organic molecules to even biomolecules. Okay, actually, around 70 to 80% of published literature on chromatography are actually based on reverse phase chromatography, no? Ganoong ka-robust, okay? Ganong ka-dynamic yung separation mode na ito. Okay? So it's effective for separating homologs. When you say homologs, these are para structurally related molecules, no? Structurally related molecules meaning yung skeletal structure nila ay almost similar. Okay? Now, since the stationary phase is non-polar and the mobile phase is polar, so if you have a mixture of compounds, the first to elute would of course be the more polar groups, while the last one to be eluted would be the least polar components. Okay? The good thing about reverse phase chromatography is that it stabilizes easily, no? Mabilis yung stabilization. When you say stabilization, normally when you have the column, no, before you start the analysis, you need to do what you call column conditioning. Okay? So gradually you change the polarity or the composition of the mobile phase from the storage solvents, as I mentioned in the previous slide. The column is actually stored, no, using a storage solvent. In the case of reverse phase chromatography or stationary phase for reverse phase, normally acetonitrile or methanol yung kanyang storage solvent. Alright, so for example, if you're going to use a mixture of say methanol and a buffer, alright, as your mobile phase, so and then your storage solvent is methanol, you cannot directly go and pump in the mobile phase because this will cause the salting out of the buffer doon sa loob ng column, which will clog up the column, of course. Okay? So you need to gradually condition the column to the conditions of the mobile phase. Alright? So normally what we do is that starting from methanol, okay, so you turn on, you attach a column, you turn on the pump, pumping in pure methanol for say around 10 to 15 minutes at a low flow rate value. Then afterwards, you decrease the methanol content by adding more water. So say you pump in 50-50, no, water methanol mixture. All right, so you can do that, no, and then increase the flow rate and then pump in for several minutes. Okay, then afterwards you go to pure water. All right, again for several minutes, higher flow rate. At this time, maybe you can already reach the analytical flow rate. Then before you pump in the mobile phase, so you call that column conditioning. Alright, so you pump in the mobile phase for several minutes also. Some package inserts will tell you to pump in at least 33 column volumes worth of mobile phase, no, before you start the analysis. So this will actually condition the column uh, with respect to your mobile phase and will stabilize, no, the baseline, okay, for the chromatographic run. Now, vice versa, when you're done with the analysis, no, for the day, you need to wash the column. So, in washing, you just do the reverse order ng conditioning. No? So, from the mobile phase, you wash it with pure water. It's a very important step, especially when you use a mobile phase containing buffers or ion pairing agents, because you want to ensure that any residual salts inside the column are washed away before you eventually fill the column with the storage solvent, no, to prevent the salting out na sinasabi natin. Alright, so you go with water while you're slowly decreasing the flow rate, then 50-50 water methanol, then finally pure methanol, and then you're ready to store the column. So when you detach the column from the unit, merong yung kasamang screw plugs, alright, to ensure that the solvent inside the column will not evaporate. So never ever let your column dry out, okay, because once it happens, it's very difficult to revive the column. Okay, one advantage also of reverse phase chromatography is that it has a long service life, no, as long as you follow the operating conditions, no, like as much as possible, do not use this at high pH. Okay, never drop the column because this will create gaps in the packing. All right, what else? Never let it dry up. Okay, nasa mga ganong klaseng protocols. Still under reverse phase chromatography, okay, you have what you call your ion suppression chromatography. So this is for ionizable compounds. Okay, so as an example, let's take benzoic acid. No? So benzoic acid, all right, structure. So benzoic acid is actually a weak acid, meaning to say it equilibrates, all right, between its protonated and deprotonated forms. No? So you have here benzoic acid, alright, benzoic acid interchanging with the benzoate form. Now, in terms of elution time, alright, if we take benzoic acid has a higher hydrophobicity compared to the benzoate form, no? So if we have the the chromatogram, sabihin natin ito yung chromatogram for benzoic acid, the corresponding chromatogram for the benzoate form would be something like this, no? So mas mabilis yung elution for the benzoate form. So in ion suppression chromatography, what you can do is to use a buffer. Alright, so with the use of a buffer, you can actually control the migration rate for benzoic acid. So if we use a low pH value, you will be promoting the benzoic acid form. So the retention time will be higher. Now, if you use a more alkaline pH, no, for the buffer, then you will be promoting the benzoate form, which in turn will cause the faster elution of the molecule. So imagine if you have, say, a mixture containing benzoic acid and a non-ionizable mixture component rather. No? So you can uh, modify the migration rate of benzoic acid by simply controlling the pH of the mobile phase. So this can be done with other ionizable molecules. You need just to consider the corresponding pKa if you're talking about a weak acid, or the pKb if you're talking about a weak base. Alright. So next, you have what you call your ion pair chromatography. So this is another technique that can be used for your ionizable compound. Alright. So say you have a molecule that is positively charged. Okay. So as we mentioned earlier, for reverse phase chromatography, charged molecules will tend to be more attracted towards the mobile phase. So there will be lower retention time or faster elution for charged species. So one way to control their, or to retard, no? I mean, when you say you want to retard the elution, it means to say that you want to increase the retention time for that particular molecule. What you can do is that you can add into the mobile phase an ion pairing agent. No? So it means to say you simply add a molecule with the opposite charge. So what happens is that since your analyte, alright, is positively charged, and then the ion pairing agent, so ito yung ion pairing agent, okay, is negatively charged, it will form an ion pair neutralizing the charge of the analyte. No? So in effect, you are increasing the retention time. Alright? So in general, ion pair reagents comes in two classifications. No? You have yung mga anionic, okay, anionic, saka yung mga for cationic compounds. No? For anionic and for cationic compounds. No? So for anionic compounds, an example would be your tetra N butyl ammonium hydroxide. So positive charge, no, para ma-attract dun sa negative analyte. For cationic analytes, you can use sulfonic acid salts, no? So pwede yung pentane sulfonic acid, sodium salt, hexasulfonic acid, sodium salt, heptasulfonic, octasulfonic acid. You are just increasing the alkyl chain length. No? Sa pharmaceutical industry, may code yan. No? So if you're using pentane sulfonic acid, sodium salt, it's what they call peak B5. No? Pag hexane sulfonic, B6, so on and so forth. So this refers doon sa alkyl chain length. Alright, so what are the different points you have to consider in the use of ion pairing agents? No? So in general, okay, as you increase the alkyl chain length, okay, you are also increasing the retention time for the analyte with which the ion pair agent pairs to. Alright? The pH of the eluent, of course, will also influence the retention time. No? You need to consider the pH wherein the analyte is ionized so that it will pair with your ion pairing agent. Or if you have multiple analytes that can ionize, you can control the pH in such a way that the ion pair agent can selectively react with whichever analyte is in its ionized form for that particular pH. Alright, the concentration of the ion pair reagent, in general, the retention strength or the retention time for the analyte increases as you increase the ion pair agent concentration. Okay, although there's an upper limit. However, in practice, we do our best to use the minimal, okay, amount of ion pairing agent possible. Because remember, these are salts, no? And salts, in the long run, will ultimately damage our reverse phase column. Alright? So, you have to be careful. As I mentioned in the earlier slides, we have to really wash the column with water, alright, after using the column with a mobile phase that has buffer and ion pair agent. Alright? And then the proportion of the organic solvent in the mobile phase is something that you have to optimize. Alright? If you add too much of the organic solvent, this might cause salting out of the salt components, no? So you have to be very careful. And also in general, when you add organic solvents in aqueous
Next,
mobile
you have
phases,
your normal
you are
phase chromatography.
decreasing. So for
The
normal phase
polarity
chromatography, kabaligtaran
of
lang ito
the
ng reverse
mobile
phase,
phase.
no? So
So
the
this is
stationary
something
phase
we
is
need to
polar, optimize. So it's either unmodified silica or alumina, Al2O3. Alright? So if the stationary phase is polar, the mobile phase is non-polar, no? So ito yung mga hexane, benzene, xylene, carbon tetrachloride, dichloromethane. So ito yung mga common examples, no, of mobile phases, no? And one reason why this is less less common, no, less commonly used is yung solvent nga, no, they are more hazardous, no, compared to those being used in reverse phase chromatography. Okay? However, an advantage of normal phase chromatography is that it is effective for the separation of structural isomers. Okay, so yung isang advantage ng normal phase chromatography. So basically here, this is based on adsorption of solid yung stationary phase mo. Alright, so the order of elution, kabaligtaran lang nung sa reverse phase. So since the mobile phase is nonpolar, then nonpolar components will be eluted first, no? While the more polar constituents will be retained more or will have a larger retention time. Okay? One disadvantage is that the column stabilizes slowly. Okay, and it is also prone to fluctuations in retention time because of the stronger polar interactions, no, from with the stationary phase, and because of the polarity of the stationary phase, there can be issues with irreversible adsorption of polar contaminants, no. So in short, uh, you can expect shorter column life, no, for normal phase chromatography. Next, you have your ion exchange chromatography. Alright, so the stationary phase used are what you call ion exchange resins. So there are two types. You have your anionic exchanger and cationic exchanger. Alright, let's go back there. Now, for anionic exchanger, the stationary phase, the charge of the stationary phase is positive. Alright? Well, kasi nga anion yung analyte. Whereas for cationic exchangers, the charge of the stationary phase is negative. Now, resins or polymeric resins are the more common material used as ion exchange stationary phases. Although silica gel can also be used, no? You just set the pH at high, no? A high value, no? Sa beyond 8, no? Beyond 8. So silica gel can serve as a cationic exchanger, no? By having deprotonated silanol groups which are negatively charged. Now for resins, all right, the ion exchange resin can be classified either as a strong exchanger or a weak exchanger. All right, for an ion exchange resins, no, Yung mga strong type nito has the functionality of a quatermonium ion, no? 3 plus, no? Quatermonium ion. Whereas yung weak anionic exchangers, all right, would have something like this, no? So parang uh, yeah, no? Hindi hindi puro alkyl group yung nakakabit dun sa nitrogen. So quatermonium ion din ito. Alright, so this is a weak cation exchanger. Alright, for anions, no? Anions. For cation exchangers, no? So the strong cation exchanger type would be based on sulfonates, no? Sulfonate group. Whereas the weak version usually are based on the carboxylate group. Okay? Yeah. What else? So the mobile phase are aqueous buffer solutions, all right, which contains salts, no, salts that has a charge counter to that of the stationary phase being used. Okay, so the order of elution for ion exchange chromatography is that, no, so for, this is again for ionizable compounds, no. So in terms of pKa, those with higher pKa will be eluted faster. Why? Because these molecules are has a lesser tendency, okay, to be ionized. Okay, kasi the more ionized you are, the more attracted you are towards the stationary phase. Yun yung rule ng ion exchange. So you will be retained more. Alright, so that's why those molecules that has lower pKa will tend to be eluted last. No? So this is considering an alkaline mobile phase. Okay? Or in terms of valency, no, monovalent compounds or monovalent ions. So kasi ang ion exchange chromatography can also be used for inorganic ions. Mga chlorides, sulfates, nitrates, or sodium, aluminum, barium ions. So pwedeng gamitin ng ion exchange chromatography doon. So monovalent compounds will be eluted first, whereas polyvalent compounds or ions will be eluted last, no? Because the greater your charge, the more attracted you are to the stationary phase. So shown in on the right is the mechanism, all right, for the elution of your analyte, all right. So say you have a anionic exchanger, no? So positive charge yung resin natin. So these negatively charged ions are the anions present in the eluent. No? A common solution used as a mobile phase are those based on sodium carbonate. So mga carbonate-based buffers. Alright, so this could be your carbonate ions. Alright. Now what happens is that when your analyte, so this one, when your analyte goes through the column, okay, since it also has a negative charge, it is also attracted towards the resin, no? The positively charged resin. However, the interaction does not happen directly. Okay? For your analyte to interact with your resin, it needs to bump away the an ion, no, initially attracted to the resin. So this is what you refer to as ion exchange, no? So as you can see, as it goes through the column, it undergoes repeated attraction, parang ang tawag ito, repeated na pagkabit at pagkalas, no, ng analyte doon sa resin, no. So series of ion exchange interaction. Okay, so here shown here, no, and something that you have to realize is that the ionic strength of the mobile phase is an important factor in ion exchange chromatography, no? Not only the pH. So in general, the higher the ionic strength, okay, it means to say that you have a higher concentration of the counter ion, no, that is competing with your analyte, no, for the when interacting, no, with the stationary phase. So what will happen is that if you have greater ionic strength, more competition for the analyte, this will lead to lower retention time. Okay, kasi the analyte has a lesser chance, alright, to interact and be retained by the stationary phase. No? So it's an important parameter. Another important parameter is of course no yung pKa and pKb of the uh, stationary phase. Alright? So you need to properly select or optimize the mobile phase so that it will be compatible no, with your stationary phase. Because if you use the wrong pH, for example, the stationary phase will not be that ionized. No? So it will not be functioning as a good ion exchanger. Temperature is also an important parameter in ion exchange chromatography. Okay, as the temperature increases in general, retention time also decreases. Sulat natin yan. No? So as you increase the temperature, alright, the retention time also decreases. Alright, because you are uh, preventing, no, or you're preventing your analyte from interacting efficiently, no, with the stationary phase. Also, the type of the counter ion, the salt, no, added into the mobile phase, the type of the counter ion used will also affect your retention time. No, if you're using strongly adsorbing ions, okay, then the analyte will elute rapidly, so shorter retention time, because it will be more difficult for the analyte to compete with the mobile phase counter ion. Vice versa, if you're using a weakly absorbing counter ion in the mobile phase, then the retention time for the analyte would be higher, no? Because it's easier for the analyte to um, dislodge, no, or compete with the counter ion. So again, this is your ion exchange chromatography. So lastly, we have your size exclusion chromatography. Now, the main difference of SEC with the other three types, no, of separation modes is that this is not based on the interaction of the analyte with the stationary phase. So, wala yung mga polar, non-polar interactions. But rather, the stationary phase serves as a sieve, pansala. Okay? So here, as name implies, we are separating the components of the mixture based on their relative sizes, no, or relative molecular weights. No, that is why SEC is widely used for the analysis of polymers, biomolecules, no. So ito yung mga malaking molecules, so macromolecules. Alright? More for determining molecular weights. Okay? Yeah, molecular weight determination. No? So again, the separation is based on molecular size. So with dalawang klase, you have your gel permeation chromatography. Alright, so for gel permeation chromatography, the stationary phase is hydrophobic in nature. Alright, so usually resin sa mga polymeric resins ang ginagamit sa SEC. So hydrophobic in nature, and the mobile phase used are non-polar solvents. Why? Because this is for non-polar analyte or non-polar substances. So examples are polymers. So for example, you're working in a plastics company, and you want to determine whether what is the average molecular weight for polystyrene that you produce, no? Kasi may criteria yan eh. If you did not reach the required molecular weight, then the mechanical properties of the resulting plastic will be different. Okay, in general, the higher the molecular weight, mas higher yung mechanical properties, no, nung plastic. Okay, so you can analyze those using gel permeation chromatography. Alright, so again, this is for large hydrophobic molecules. Gel filtration chromatography naman are for polar solutes. Alright, so since polar, the stationary phase is hydrophilic in nature, whereas the mobile phase ay aqueous-based. Alright, so polar. So this is usually for biomolecules or large hydrophilic molecules. Now for both SEC modes, alright, the order of elution is mauuna, no? First to elute will be the larger molecules followed by the small molecules, no? So bakit ganito yung order of elution? Okay? It has something to do with the nature of the stationary phase. Alright? The stationary phase used are porous in nature. Okay? So, ito yung ano, no? So, what happens is that the large molecules, since they are too large, they won't be able to fit into the pores of the packing material. So, instead of going through the pores, they will go through the gaps, which are larger and more easier to go through, no, for large molecules. Whereas for smaller molecules, smaller components, since they are small, alright, they will tend to go through the pores of the stationary phase. So it will take them longer time to go through the whole length of the column. So that's why they have higher retention time. So ito yung sasabing size exclusion chromatography. Now when rating the stationary phase for SEC, you have to consider yung exclusion limit na tinatawag, okay? And yung permeation limit, no, na sinasabi, no. So this will guide you, okay, regarding which stationary phase to use, no. You need to have an initial assessment, no, of the relative molecular weights or molecular sizes of the analytes, no, or the components of your sample, no, before choosing the appropriate stationary phase for SEC. So next we have the detectors for HPLC. Alright, so the choice of detector depends on the nature of your analyte. Okay? So, one of the most common detectors are those based on absorbance measurements. Ito yung UV vis detector. Okay? So, if you remember, no, it's actually for compounds or analytes that have chromophores. No? So, pag walang chromophore, you cannot analyze that compound, no, using absorbance detectors. Okay? Next, you have your fluorescence detectors, and this is for fluorescing substances. No? So, as you can see here, the detectors applied for liquid chromatography are either based on optics, no, spectroscopy, or based on electrochemical detectors. Okay? So, fluorescence for fluorescing substances. The universal detector for HPLC is your refractive index detector. No? So, as the name implies, what you measure here is the change in refractive index. Now, being a universal detector, as what we mentioned in gas chrom, this is also the detector that has the lowest sensitivity, no? Kasi nga hindi siya ganoon ka-selective. No, unlike yung absorbance kunwari, it's selective towards chromophore containing compounds. You can even improve the selectivity further for the absorbance UV vis detector by looking at the lambda max for the analyte or analytes of interest. Alright? For refractive index detector, normally ang pwede mo i-analyze dyan mga sugars. No? So for the analysis of sugars, since sugars do not contain strongly absorbing chromophores, alright, typical na ginagamit ang refractive index detector. Even for the analysis of yung mga gel permeation chromatography, alright, since relatively abundant yung analyte dun sa injected sample, okay, then you have the you usually use the refractive index detector, no, para mas cheaper. Alright. Evaporative light scattering detector are for non-volatile substances, normally for macromolecules. Alright, so polymers or more commonly for proteins, no, for protein analysis. Then you have yung mga based on electrochemical detectors. So you have your electrical conductivity detector for ionic substances. If you're doing ion chromatography, then normally you have this. Amperometric detectors are for redox active substances. Alright? And then, of course, you have the hyphenated technique LCMS, no, wherein you uh, tandem, no, the LC unit with a mass spectrometer. Alright? Now, another important thing to consider is whether the detector is okay for a gradient system. Alright? Not all detectors are compatible with gradient elution. No? So, you need to take note of these listing here. Okay, so shown here are the different detectors, okay, for each PLC. No? So, ito yung UV-Vis detector. Alright, so instead of a cuvette, what we have here is what you call a flow cell. No? So, yan, flow cell yung tawag dito. The flow cell is constructed from quartz. Okay, so similar to what we discussed in UV-Vis spectroscopy, all the elements of a UV-Vis spectrometer is present here in the detector. So, one advantage of instruments is that you can miniaturize, no? Miniaturize any instrument design. Alright, so you also have a light source here. For UV-Vis detectors, they are equipped with both the deuterium lamp as UV source and the tungsten lamp as UV source. So the same precautions are observed, no? Consumable yung light source, no? So from time to time, you have to check whether you need to replace the light sources. Alright, so you also have your gratings, alright, and then your detectors. Detectors can either be photodiodes or photomultiplier tubes. Okay. You can also use photodiode arrays, no, if you want to improve the analysis. Okay, so with the use of photodiode arrays, aside from the peaks, alright, each peak will also have their corresponding UV-Vis spectra. So you will get more information from that. However, it has lower sensitivity compared when you use a photomultiplier tube. Okay? So, yan, no? Ang hindi mo lang pwedeng gawin with UV-Vis detectors is that you cannot do wavelength scanning. Alright? So, in lieu of wavelength scanning, if you want to record the spectra, you need to use a photodiode array, no, as I mentioned. Next, you have your fluorescence detector. Ito. Alright? So, again, no, as you can see here, the light source, alright, and the detector are perpendicular from each other because you want to record the fluorescence of your molecule. Okay, so quartz yung material ng flow cell. Alright, the light source usually uses xenon lamp din. Okay, um, among the spectroscopic or among the detectors also, no, for LC, aside from mass spec, no, mga sali yung mass spec, fluorescence detector will be the most sensitive, no? It has the lowest LOD, LOQ values. Okay, however, the limitation of fluorescence detector is that this is only for fluorescing substances. Okay? Alright, so next you have your refractive index detector. Alright, so this is based on the measurement of the refractive index, okay, of the flowing solution. No? So the refractive index for the mobile phase is recorded as your baseline so that when the uh, mobile phase containing now the analyte, okay, yung refractive index nun would be different from that of the pure mobile phase, no? So this is the universal detector, and hence it has the lowest sensitivity. Okay, this one is your evaporative light scattering detector, and this is used for protein analysis. All right, for large molecules. No? So basically here, okay, when the effluent coming from the column goes through the detector, all right, you have a nebulizing gas which will form an aerosol, no? Aerosol with the LC eluent, all right, and then the resulting solute, no, yung mga solute molecules na desolvated, will go through the detector. Alright, so you have a light source, then you have the detector. So the scattering of light caused by the presence of the solute particles will be recorded as your detector response. Okay, so this is your evaporative light scattering detector. Okay, so next you have your electrical conductivity detector. So basically you have electrodes here wherein alternating current is allowed to pass, no, between these two electrodes, no. So the baseline conductivity is measured, no, in the absence of the analyte, so that when an element containing the analyte passes through, the change in electrical conductivity will be recorded as your detector response, no. So normally this is used for ion exchange chromatography, no, kasi ions yung analyte natin. Now, if you have redox active substances, a more sensitive detector would be your amperometric detector. So this is based on amperometry, no? So the detector here contains the three electrode setup miniaturized. So you have the working electrode, counter electrode, and reference electrode. Now the potential at the working electrode is set towards the redox potential, no, for the analyte of interest. So whether you're inducing oxidation or reduction. So the resulting current change because of the redox reaction will be recorded as your detector response. Alright, so lastly, you have your mass spectrometer, no? Yung hyphenated or tandem instrumentation. So, from the HPLC unit, alright, to introduce a sample to the mass spec unit, you need to have an atmospheric pressure ionization unit, no? So, this uses either yun nga, yung APCI, or you can also use the electron spray ionization, no? Ito yung mga common ionization sources, no, for LCMS, no? Then of course you would have your mass analyzer and the detector, no? So this is the most sensitive, no, among the detection techniques for LC. So similar to your GC, with an LCMS unit, you would have the separation power of a liquid chromatograph, and at the same time the ability of a mass spec, no, to give you the identity of an unknown component. So also you can tandem, no, your LCMS, no, by using multiple MS units, no. So yung mga LCMS-MS or LCMS-MS-MS, so tatlong MS units yun. Normally these are used for the analysis of macromolecules, no. For example, in proteomics, you want to determine the structure of a enzyme. Alright, so you want to break down the enzyme into several fragments, no. So you can do that by using multiple mass spectrometers, alright, in tandem with your LC unit. Sample preparation methods for HPLC are less tedious, no, compared to your gas chrom na marami kang extractions, no. So normally for HPLC, you just need to dissolve your sample. For more complicated samples, maybe you need to digest the sample, no, prior to dissolution, no? So these are the common sample preparation techniques for HPLC. Solid phase extraction can also be used, no, for HPLC, no. Yeah. Derivatization is also an option for HPLC analysis. May dalawang klase. You have your pre-column derivatization and you have your post-column derivatization. So when you say pre-column derivatization, before you inject your analyte, no, your sample into the chromatograph, you do some reaction. Okay, you react your analyte, no, or your sample with derivatizing agents. The purpose of pre-column derivatization are twofold. So yung number one is to modify or improve to your liking the migration rate of the analyte, and at the same time improve its detector response, no, yung detection response sa kanya, by adding functional groups, no, appropriate for the detector being used. So for example here, common derivatization agents, no, are your ortho-talaldehyde for primary amines and 2,4-dinitrophenylhydrazine or yung 2,4-DNPH for aldehydes and ketones. So in general, this adds chromophoric groups to your otherwise non-chromophore containing analyte, no? So for detection ng UV-Vis detector. Now, for post-column derivatization, a reactor, no, a miniaturized reactor is attached toward in the end part of the column, so that the flowing eluent coming out from the column will first pass through this reactor before reaching the detector. Okay, so this is post-column derivatization. And the purpose of post-column derivatization is to improve the detector response, no, by adding the required functionality for detector response, no. So when you do post column derivatization, you're not modifying the migration rate, no, you are just improving the detector response. So some common uh, derivatization agents for post column method, no, for amino acids, for example, you can add orthotalic acid or ninhydrin. Okay, with orthotalic acid, you're enabling fluorescence detection. So for trace analysis siguro, no, ng proteins. If you want to use visible detection, no, UV-Vis detector, then you can use ninhydrin. For sugars, no, reducing sugars, you can add arginine to allow fluorescence detection. All right. For carbamate pesticides, no, you can do alkaline hydrolysis followed by orthotalic acid for fluorescence also. Bromate ions, okay, so ion exchange chromatography, okay, you can improve detection of bromate ions by, say, tribromide ionization, no, so for UV-Vis absorption, or the addition of orthodianicidine, alright, for visible absorption. Cyanide ions, one way to do this is by chlorination followed by addition of pyrazolone, so that the a UV detector can be used, okay, for greater sensitivity. For some transition metal ions, again for ion chromatography, you can add this resorcinol compound, alright, no, parang sa concept nung iron phenanthroline, no, you form a charge transfer complex which is colored, no, so that you can detect these ions via visible detectors, no, UV-Vis detectors. Okay, so that's it for part 3 of module 9. So again, we will be posting the self-assessment exams in our FB group page.